Hello and welcome to Group 9's BIM documentary video. This is task 2 for module KB 5022, Construction Project Management and Digital Design Engineering.
The first section is prevailing protocols and standard approaches to collaborate working within the integrated architecture, engineering and construction practices. One of the key developments within the AEC sectors over the last few years has been the emergence of BIM. BIM is seen by many within the construction sector as a way of reducing waste, cutting costs and generally producing a more efficient, leaner and better performing construction sector. Collaborative working practices have been identified as being key to achieving the aforementioned efficiencies. But at present, many graduates are not experiencing such scenarios within their undergraduate experience. This aims to provide an overview of how academics at the University of Ulster are working together to overcome the problem by encouraging students on the architectural, technology and management and quantity surveying and commercial management programs to work collaboratively on a project. The project will be contextualized around common industry practice. The aim of this partnership is to increase student understanding of the collaborative working practices within construction. Also, how BIM processes facilitate the more effectively than traditional project team practices. In the majority of universities in the US, Europe and Australia, architecture, engineering and construction students continue to be educated in separate departments with little or no integration or collaboration between the disciplines. Often the first time that students from each AEC discipline are exposed to working with design team members from other disciplines is in the workplace after graduation. It is important for graduates to have an understanding of the roles played by other construction professionals and the impact that their design decisions have on projects overall. However, the isolated manner in which they are currently educated does not provide this understanding. Many educators still view BIM as yet another CAD program that students should learn in their own time. However, the argument misses the point that BIM is not merely a new CAD tool or computer application, it is a new paradigm, and its benefits extend far greater than mere visualization.
This next section is about the role of an advanced project monitoring tools in expediting error detection and prevention in AEC projects. Project monitoring services are the services that include a range of different client types. A funding institution which will help acquire the project as an investment upon completion of the given project. A tenant or purchaser who will commit to lease or purchase the project upon the completion. A bank or development finance company that will fund the project. Grant funders can also fund the project as well as a bank on top of this, and also private finance initiative funders, also known as PFI. Some issues covered by project monitoring: land and property acquisition, statutory consents, issues relating to the developer and project management systems, financial appraisals from banks, construction agreements between subcontractors and their contractors themselves, costs of the project, the program outlay, and design and construction quality. And the advantages of project monitoring: enhanced risk assessments for the site, an enhanced financial management so everybody knows exactly what costs they are to meet, an enhanced program management so that they can make a more improved project than a standard one, enhanced quality management meaning that you would be able to run the site in a more efficient manner, greater protection of the client's interests, so following the client brief with more detail and making sure that every little detail is met, and better informed decision making. Expediting is a part of project management. The purpose of this is for purchasing project management for securing the quality and timely delivery of goods and components for the projects. The procurement department or an external expediter controls the progress of the manufacturing stage at the suppliers concerning quality, packing, conformity with standards and set timelines. The expediter makes sure that the required goods arrive at the appointed date in the agreed quality at the agreed location to avoid confusion or delay. needed in more large-scale projects. There are a few different levels of expediting, one of which is production control, which is where the expediter will inspect a factory and whether the production is up to the standards of the country the goods are destined for. This is especially necessary for food and engineering equipment like power plant components. They control whether the regular audits for the ISO 9001, etc. have been made. There's another type is quality control. The components are tested and whether they function as required, whether they are made to the measurements and standards of the customer. As part of this quality control, they can be tested for compliance with the standards of the destination country, like Euro codes and British standards. So another level of this is packing/transport surveys. This is the lowest and most used level of expediting, as the goods are only counted and the packing is controlled whether it withstand the adversities of transport, like i.e. weather conditions and things like that. Another level of expediting is the main one, project management. At large-scale projects, not only goods are controlled, the expediter will also keep an eye on the deadlines and milestones of the project and whether the supplier will be on time as well. A main type of expediting is field expediting. This provides clients with a comprehensive review of the precise standing of their order and any on-site action to rectify any potential problem areas. Field expediting means the inspection and control of the expediter on site. This gives clients a comprehensive review of the exact current status of their order and an educated projection of future planning and status. As well as this, while being on site, experts for expediting can identify possible problems and bottlenecks that could lead to potential delays. Another type of expediting is desk expediting. It is an important tool for producing companies to monitor and order progress with manufacturers. Desk expediting can be helpful to check whether the project is still within the agreed schedule. Contact is established at specific milestones within with the order fabrication method, and a brief outline of status should be given. An expediter will very quickly assess whether the order is progressing consistent with the plan or whether the alternative methods are needed to verify and presumably improve the order's progress. Desk expediting is best used with field expediting.
This section of the presentation is on advanced decision support and project information management tools in AEC practices. Decision support systems, or DSS, are an information that supports businesses or organizational decision-making activities. DSSs serve all aspects of a company, but typically are used in the mid to high management sector, and help people make decisions about problems that may be rapidly changing or that are not specified. Sprague 1980 defines a properly termed DSS as follows. DSS tends to be aimed at the less well-structured, underspecified problem that upper level managers might face. They attempt to combine the use of models or analytic techniques with traditional data access and retrieval functions. They also specifically focus on features which make them easy to use by non-computer proficient people in an interactive mode, and can emphasize flexibility and adaptability to accommodate changes in the environment and the decision-making approach of the user. The early framework of a decision support system consists of 4 core phases, these being intelligence, design, choice, and implementation. Holsapple and Winston classified DSS into the following 6 frameworks, these being text-oriented DSS, database-oriented DSS, spreadsheet-oriented DSS, solver-oriented DSS, rule-oriented DSS, and compound DSS. A compound DSS is typically the most popular classification and is a hybrid system that includes 2 or more of 5 basic structures. The support given by a DSS can be separated into 3 distinct interrelated categories, these being personal, group, and organizational support, and the DSS components may be classified as inputs, being the factors, numbers, and characteristics that need to be analysed, the user knowledge and expertise, these being the inputs requiring manual analysis, outputs, which is the transformed data which the DSS decisions are generated, and the decisions themselves, which are the results generated by the DSS. Decision making is a necessary process throughout the entire development cycle of any investment project. The pre-investment phase requires decisions with regard to the feasibility, location of the investment, or the selection of the design. In the construction phase, decisions are made to solve technical and transport-related problems, as well as to optimize the use of the accessible construction site. The operational phase is the decisions made that are associated with the possible restoration or renovation or extension. A situation in which a given entity or the decision maker is faced with the necessity to choose from at least two options. In many cases, the decision-making process is so complex that it requires construction of a simplified model of the decision problem. These models present a fragment of reality which is significant from the perspective of the decision problem. Several types of models can be distinguished, such as verbal, analog, and symbolic models. The mathematical model, which allows for the use of computer-aided methods to choose from the optimal solution, is particularly useful for decision-making problems. Project information management is specifically focused on managing the large volumes of information that is generated by any project. Any project will involve huge volumes of drawings, documents, and emails with multiple versions of each arising throughout the life cycle of the project. Effectively managing this data has commercial and contractual implications. During the project and following the completion, easy access to drawings, documents, spreadsheets, certificates, and emails represents a substantial asset and is a key component in any project information management solution. Formal project information management solutions provide a secure environment for all project communication. This ensures that all drawings, documents, and correspondence can be easily accessed with a comprehensive audit trail. The advantages of using project information management include an enhanced quality and accuracy, as drawings and documentation production is controlled and the standards are preserved. Another advantage is increased productivity, as simplified document and email management processes keep teams organised and keep deadlines on track. BIM also leads to improved collaboration between all parties involved and also leads to a mitigated risk. The limitations of BIM, however, when specifically using intranets and extranets, are there are no drawings or document file metadata, making search an onerous task. Lost files or inaccurate filing could make it difficult to find the drawings, documents, and contracts needed. There can also be doubt as to which version represents the final document or which was the pertinent revision relative to the specific inquiry. With intranets and extranets, there isn't always an audit trail of the drawn and document changes and to whom they were distributed to. There can also be an omission of security and access controls and individuals not following standard procedures when archiving project documentation.
The potentials and barriers of adopting digital engineering, BIM, and integrated project delivery within AAC domain. The first part of this is the lack of client interest. For example, some clients are afraid to experiment with new ideas that have been introduced. They're also afraid because of this, due to the excess expense that can occur due to the integration of new BIM technologies. Clients cannot be forced to adopt BIM, even if some people may deem it pertinent to do so. Many smaller businesses have also not adopted BIM due to the lack of need. BIM is not required for some projects, as most BIM practices apply standard practices, and these are sometimes not useful for unique projects. This means the cost of value ratio for BIM can sometimes be not as much as would be expected. For example, a lot of BIM software like Revit, ArchiCAD, and BIMX only focus on one specific area, design. This means installing these for projects that might not need design aspects would be a waste of funds. So also, some ambitious projects may not be able to be replicated on these specific types of software. So BIM can have less benefits on smaller projects. So while BIM can help with overall cost effectiveness, this might not be the case for smaller companies. For example, Archibus could be considered over the top, as it could be easier to use paper or a calendar application due to the smaller timescale of some projects. For example, projects like the boathouse, Revit does allow us to design the boathouse, but it might be over the top for a specific project, as it could be completed with old-fashioned techniques like drawing at a lesser cost. A potential barrier for BIM implementation would be the high cost, as while the initial cost of implementation might not be a major problem for most companies, the streamlining of all the programs into one system can. This streamlining of BIM project into normal working might be frustrating to workers as well. Some smaller companies may not implement BIM due to this initial cost. Say, for example, they only occasionally need to use the software on some projects, but not all, so it'd be a waste of money to do it all the time. The boathouse, for example, is a small project and may not require the costly implementation of BIM. Another barrier may be the lack of BIM experts. Due to the only recent BIM introduction, there are a lack of experts on this specific subject, meaning trainers are harder to find and therefore will be more expensive. Training will also take valuable time that could be spent doing other older techniques that, while taking more time, may on average take the same time as the training and the BIM techniques. For projects like the boathouse, implementation plus training in BIM for this one small project may not be worth it.
This final section of the presentation will focus on the conclusions and links to the Level 5 Cragside project and ask the question, is BIM worth it for this project? As can be drawn from all of the information that has been gathered and presented in this video, the BIM process does have a number of different components and aspects to it. Some of these components may be easy to learn and are cheap to carry out, but other aspects are the polar opposite. They are expensive and not easy to learn. As far as the project for the boathouse is concerned, some of the aspects of BIM could be useful, and they are discussed as follows. The project monitoring tools and error detection tools will be very useful to the Cragside Boathouse project. This is because Cragside is a National Trust site, and all of the materials that are used for this project will need to be okayed by the site, but also the site needs to be protected from any potential outbreaks from the construction site. And it also needs to be done quickly to reduce the amount of revenue lost to the site by tourists that may be put off during construction works. It would help this time constraint by setting out exactly what is needed by all of the parties concerned, from the contractors to subcontractors, any suppliers and the clients themselves, and this would prevent delays from occurring. The use of the project management information tool would also be useful, as it would provide everyone with a structure to follow, and it would help to reduce the amount of time that is delayed through misplacement of documentation relevant to the site, provided that all of the procedures listed within the project management information tool is followed at all times. In conclusion, while BIM definitely has its uses, more needs to be done to educate people about it. But this education is not just about how to use the software and the processes, but also about promoting it to companies and interested parties about the benefits of BIM.